Kia ora tātou katoa. My name is Millan Ruka. I come from Taitukatau Whangarei, up here in the north. My long-held aspiration is to harness water energy, but in a sustainable way. I'm the inventor of the Ruka turbine. 13 of 15 of my father's family were born on the banks of the Wairua River. Ko ahau te awa, ko te awa ki ahau. I am the river is me. Since 2010, I've dedicated my life to kaitiaki, te awa, to manaaki and care for our rivers. In the Pacific region alone, we have great resources in our rivers, harbours and oceans, for example, and yet we still rely greatly on coal, diesel and gas for electric power generation. Existing water turbine technology is not commercially suitable or viable to be used in many of our world's harbours and rivers. Propellers need great depth to operate. Their energy capture blades are inefficient to the resource. Environmental harm develops with electric currents and sharp blades. Deployment and maintenance is difficult and costly. Water wheel technology is said to be more than 2,000 years old, developed by the very innovative Greeks. The Ruka marine turbine evolved from Mātauranga Māori, Te Ao Māori, our way of thinking. Water wheels were the key to the origin of the Industrial Revolution in the early 1800s. They are radial in design and operation. Today's marine technology is still radial in design, but now in propeller version, such as the Open Hydro in the Orkney Islands, Scotland. The radial propeller marine technology derives from wind turbines, but since the late 1990s have been adapted to underwater environments, as you see here in the Shegen marine turbine in Ireland. Apart from innovative deployment methods, any further advancements with radial technology itself are considered to be unlikely. The orbital marine power turbines here are still on this 680-ton vessel. They're still basically the wind turbine propeller, but immersed in the water. The world has an abundance of high-capacity rivers like the Clutha and Otago, but radial turbines need larger diameter blades and are not commercially viable in the 3 to 4 metre average depths. In this example here, the Clutha is 3 or 4 metres deep and has 2,456 tonnes of water passing under it every 4 seconds. The RMT elongated design is very efficient to harness slow and swift currents to meet commercial kilowatt output. It has low to zero impact on the environment. With 114 dams in New Zealand, like the Roxburgh Hydro Dam, we have ideal locations to recycle the swift flows that exit below each dam. These locations have all the infrastructure in place ready to be utilised. The Aratia hydroelectric power dam is one of 9 on the Waikato River, ideal for the Ruka marine turbine. The 1911 Wairua power station has great detrimental impact on the eel fishery of the upper Wairua River catchment. The RMA this year has considered another dam, almost a replica of this one. Aotearoa is blessed with natural water current resources. We need to consider how best to utilise these natural forces with zero impact on the environment. The Ruka marine turbine will be floating low draft pontoon or barge type vessel. Mooring methods are conventional, so the Ruka marine turbine is very adaptable to supply power to remote locations such as the Hokianga, French Pass and the Manukau Harbour. Climate change is upon us. The world needs clean energy alternatives. The Ruka marine turbine is a charitable project. My desire is to provide turbines to the world, in particular those nations that can least afford it. Prototype has been designed. There's still some variations to go. in the Accelerator program with CHQ and Callaghan, and provisional patents are now being prepared, and we're moving ahead with the project. Bill Gates quote, "Climate change is the greatest threat to our existence in our short history on this planet. Nobody's going to buy their way out of its effects. Māori have a whakatauki, he waka iki noa. We are all in this together."